Vacuum fluctuations. For a long time, scientists believed that empty space was truly empty. Nothing in it, nothing happening, just a cold and silent void stretching across the universe. NASA's observations, combined with quantum physics experiments, shattered that assumption completely. What we call empty space is actually boiling with invisible activity. Tiny particles are constantly popping in and out of existence, appearing from nothing and vanishing just as quickly. These are not hypothetical particles or mathematical tricks. They are real, and their effects have been measured and confirmed. The energy they produce is called vacuum energy, and it exists everywhere in the universe, even in the deepest and most remote regions of space where nothing else exists. Scientists had assumed that if this energy existed at all, it would be either zero or incredibly small. Instead, it turned out to be one of the most powerful and widespread forces in the entire cosmos. NASA's deep space observations showed that this invisible energy is actually driving the accelerating expansion of the universe, pushing galaxies apart at an ever-increasing speed. Every model scientists had built about how the universe would eventually slow down and stop expanding had to be thrown out. The universe is not slowing. It is speeding up, powered by the restless energy of what was once thought to be nothing at all. Martian methane. Mars was supposed to be a dead world. Geologically inactive, atmospherically thin, and completely hostile to any form of chemistry that could suggest life. NASA's Curiosity rover changed that picture in a way that nobody was prepared for. While slowly making its way across the floor of Gale Crater, the rover's instruments detected sudden and significant bursts of methane gas rising from the ground. This was deeply unexpected. On Earth, the overwhelming majority of methane in the atmosphere comes from biological sources, living organisms producing it as a byproduct of their basic functions. The detection alone was not proof of life, but it was proof that something on Mars was actively producing a gas that, by all prior models, should not have been there at all. What made this even harder to explain was the pattern. The methane appeared seasonally, rising during warmer months and fading during colder ones. That kind of rhythmic behavior suggested a process tied to temperature, possibly something locked beneath the surface that becomes more active when the ground warms. Scientists had to completely revise their understanding of Martian chemistry. The planet they had declared chemically inert was clearly doing something beneath its surface. Whether it is a geological process or something far more significant, nobody has been able to definitively answer. But the certainty that Mars was a dead and unchanging world was gone. Water on the Moon. The Moon was considered completely dry for decades after the Apollo missions. Astronauts brought back hundreds of kilograms of lunar rock and soil, and scientists analyzed all of it extensively. The conclusion was consistent and firm. The Moon had no water, no ice, no hydration of any meaningful kind. It was a bone-dry rock orbiting a planet that happened to have abundant water. NASA's Lacrosse mission in 2009 ended that conclusion permanently. The mission deliberately crashed a rocket stage into a permanently shadowed crater near the lunar South Pole and then flew a sensor-equipped spacecraft through the resulting plume of debris. What came up from the impact was not just dust and rock. There was water ice, a significant and confirmed amount of it, hiding in the frozen darkness of craters that had not seen sunlight in billions of years. Further missions and analysis revealed that water ice was not isolated to one crater. It existed across multiple permanently shadowed regions, and later data from NASA's SOFIA observatory found evidence of water molecules on sunlit parts of the lunar surface as well. The Moon that scientists had declared a dry world turned out to be holding water in unexpected places and in unexpected forms. This completely changed the conversation around future lunar exploration and the possibility of using the Moon as a long-term base, since water can be converted into breathable air and rocket fuel. Saturn's rings are young. Saturn's rings are one of the most iconic and immediately recognizable features in the solar system. Scientists assumed for a long time that these rings were ancient, formed in the early days of the solar system alongside the planet itself, and therefore roughly 4.5 billion years old. NASA's Cassini spacecraft, during its final orbits diving between Saturn and its rings, gathered data that completely upended this assumption. By measuring how much material was falling from the rings into Saturn's atmosphere, scientists were able to calculate how fast the rings were eroding. The rate was startlingly high. Based on that rate, the rings could not be more than a few 100 million years old at the absolute most, and possibly as young as 100 million years. In cosmic terms, that makes them extraordinarily recent. The dinosaurs were still alive on Earth when Saturn may have acquired its rings. This raised immediate and uncomfortable questions. Where did the ring material come from so recently? The leading theory is that a large moon or comet wandered too close to Saturn and was torn apart by gravitational forces, with the debris spreading out into the ring structure we see today. But the timing is strange. Saturn has had its rings for only a brief fraction of its total lifespan, which means we happen to live in the narrow window of time when they exist. Scientists had to accept that one of the most visually defining features of the solar system is a temporary structure, not a permanent one. Pluto's heart. When NASA's New Horizons spacecraft flew past Pluto in 2015, scientists expected to find a geologically dead and crater-pocked surface. Pluto is small, cold, and extremely far from the Sun. There seemed to be no source of energy significant enough to drive any active geology. What the spacecraft's cameras revealed instead was shocking. On one side of the dwarf planet, there was a vast and smooth plain of nitrogen ice in the shape of a heart, now formally named Tombaugh Regio. The surface was not ancient and cratered. It was geologically young, possibly only a few million years old, meaning it was being actively renewed by some internal process. Nitrogen glaciers were flowing slowly across the surface. Evidence of possible cryovolcanism, volcanoes that erupt ice and slush instead of molten rock, was found in multiple regions. There were mountains made of water ice rising several kilometers above the surface, tall enough to rival the Rocky Mountains on Earth. None of this should have been possible for a world that small and that far from any significant heat source. The leading explanation involves radioactive decay in Pluto's core generating a small but persistent amount of heat, possibly enough to maintain a liquid ocean of water beneath the ice. But scientists are still working through exactly how such a small and cold body manages to remain geologically active. Pluto forced a fundamental revision in the understanding of how small icy worlds behave. Titan's lakes and rain. Titan, Saturn's largest moon, had long been theorized to have a thick atmosphere, but the details of what lay beneath that orange haze were almost entirely unknown before NASA's Cassini mission began sending back data. Scientists suspected liquid might exist on the surface, but they imagined it would be spread broadly and shallowly. What Cassini revealed was a world with a full and active hydrological cycle, meaning a system of evaporation, cloud formation, rainfall, and flowing rivers that carved out valleys and collected into lakes and seas. The crucial difference from Earth is that the liquid is not water. Titan is far too cold for liquid water to exist on its surface. Instead, the entire cycle runs on liquid methane and ethane. There are methane rainstorms. There are rivers that carved channels into the landscape over geological time. There are vast lakes near the poles, some of them larger than the Great Lakes of North America, filled with liquid methane sitting calmly under a hazy sky. Scientists had theorized that hydrocarbon lakes might exist, but the scale, the complexity, and the clear evidence of active weather was far beyond what the models predicted. Titan now stands as the only world in the solar system other than Earth with stable liquid on its surface and an active weather cycle. The assumption that complex, Earth-like environmental systems required Earth-like conditions was proven wrong by a moon of Saturn. Black holes in the early universe. For decades, the accepted model of how black holes form and grow followed a clear and logical progression. A massive star collapses, forms a black hole, and then over enormous stretches of time, it gradually accumulates mass by pulling in nearby material. Supermassive black holes, the giants that sit at the centers of galaxies, were assumed to have grown through this slow process over billions of years. NASA's James Webb Space Telescope, peering further back in time than any instrument before it, found supermassive black holes that were already incomprehensibly large when the universe was less than 1 billion years old. These were not small or medium black holes in an early stage of development. They were already billions of times more massive than the Sun, fully formed giants sitting at the centers of early galaxies, at a point in cosmic history when the standard model said they should barely have gotten started. Scientists had no mechanism that could explain growth at that speed. The known physics of accretion, the process by which black holes pull in mass, has limits. There is a theoretical ceiling on how fast a black hole can eat, and these objects appear to have grown far beyond what that ceiling should have allowed. Some researchers now suggest that the first black holes may not have grown from collapsed stars at all, but instead formed directly from giant collapsing clouds of gas in the early universe, bypassing the stellar stage entirely. The history of how the universe's largest structures formed had to be rewritten. The heart of Europa. Europa, one of Jupiter's moons, has long been considered one of the most promising places in the solar system to search for life. Scientists knew it had a global ocean of liquid water beneath its icy shell, kept liquid by the gravitational squeezing it receives from Jupiter. What they did not fully appreciate until more recent Hubble observations was the scale of the activity happening beneath that shell. Hubble detected enormous plumes of water vapor erupting from Europa's surface, shooting hundreds of kilometers up into space. These geysers were coming from somewhere deep inside the moon, likely from the ocean beneath. The presence of active plumes meant that material from the interior ocean was being vented directly into space. For scientists searching for signs of life, this was a profound development. Instead of having to drill through kilometers of ice to reach the ocean, a spacecraft flying through one of these plumes could potentially sample the ocean's chemistry directly. Later analysis of data from the old Galileo mission revealed that the ocean beneath Europa is not a simple pool of water. It appears to be a salty, mineral-rich environment with a seafloor that may be experiencing hydrothermal activity, where heat from the moon's interior warms the water and drives chemical reactions at the bottom of the ocean. On Earth, hydrothermal vents on the ocean floor are surrounded by thriving ecosystems that require no sunlight. The idea that Europa was simply a frozen moon with a hidden ocean underneath was replaced by a picture of a chemically active, energetic world that could, in principle, support life. The expansion rate of the universe. Edwin Hubble established nearly a century ago that the universe was expanding. Scientists accepted this and spent decades measuring how fast that expansion was happening, a value known as the Hubble constant. They expected their measurements, once refined enough, to converge on a single agreed number. Instead, NASA's observations using the Hubble Space Telescope and later the James Webb Space Telescope revealed something deeply troubling. When scientists measure the expansion rate using the cosmic microwave background, the ancient afterglow of the Big Bang, they get one number. When they measure the same rate using nearby stars and galaxies, they get a different number. These two measurements should agree. They do not. The gap between them is large enough that it cannot be explained by measurement error alone, and the more precise the instruments become, the more persistent the disagreement is. Scientists call this the Hubble tension, and it has become one of the most significant unresolved problems in modern cosmology. The models that scientists spent generations building to describe the history and behavior of the universe appear to be missing something. There may be an unknown form of energy, an undiscovered particle, or some entirely new physical process that operated in the early universe and has not yet been accounted for. The universe is not behaving the way the equations say it should, and nobody yet knows why. Oxygen on a comet. Molecular oxygen, the form of oxygen that living things breathe, was for a long time considered a biosignature. Scientists believed that free oxygen in significant quantities was almost impossible to produce through purely non-biological chemistry. On Earth, the oxygen in the atmosphere was produced by photosynthetic life over billions of years, and before life existed, the atmosphere had almost none. When NASA supported the European Space Agency's Rosetta mission, which orbited and studied Comet 67P in extraordinary detail, the spacecraft's instruments detected molecular oxygen being released directly from the comet's surface. This was the first time molecular oxygen had been confirmed in the material of a comet, and it was present in surprisingly large quantities. The comet formed in the cold outer reaches of the early solar system more than 4 billion years ago, long before life existed anywhere. The oxygen could not have come from biology. Scientists concluded that it must have been produced by ancient radiation chemistry, where high-energy particles broke apart water-ice molecules billions of years ago and the resulting oxygen became trapped in the comet's structure. The discovery did not disprove the connection between oxygen and life. But it did demonstrate that a gas once considered nearly impossible to produce without biology could in fact be generated through purely physical and chemical processes in space. The confidence with which scientists had treated molecular oxygen as an unambiguous sign of life was shown to be premature.